Hello, I'm Anna Mackay and this video is the continuation of the topic of the angle between two vectors, and we're just going to do some examples here. So if we're told that vectors A and B have lengths of 5 units and root 7 units respectively, and the angle between them is 110 degrees, and we have to find the dot product or the scalar product AB. So let's just practice it using the formula here. So to do that, we're going to write out the dot product of A dot B is equal to, and so as you can see we've got the length and magnitude of A, and we're told that that is 5 units, and then multiplying that by the magnitude of B, which is root 7, and then multiplying that by the angle cos 110. Now what answer are we expecting? The fact that cos is an obtuse angle greater than 90, what answer should we expect for this? A negative answer. And if you substitute that into your calculator, you get negative 4.525, a negative answer as expected. If we're asked to find the angle between vector A and B, so this is the classic using of the formula here, we have to eventually find the angle, which means there are all these components that we're going to need to calculate first. So if we can do the dot product, the scalar product of A and B, I might just do off to the side here because I quite like them in square brackets. So I'm going to work out A and B, just rewriting what we see there horizontally. There's vector A and vector B. Now to do the dot product of those, we multiply the corresponding components and then add. So we've got a 3 multiplied by 1, and then we're adding on that negative 2 multiplied by 7, and that gives us 3 subtract 14, which is negative 11. We can also plan for our answer for the angle that we're going to get now. Because we've got a negative number there, what will the angle be? It will be obtuse, so greater than 90. So if your answer is not that, you know you've done something wrong, and you go back and check. Another part that we're going to need is the magnitude of vector A. So using our formula for that, it's 3 squared, adding on negative 2 all squared, and the square root of all of that comes out to be 9 plus 4, sorry. That's equal to the square root of 13. Same for the magnitude of B. We're going to have 1 squared plus 7 squared, and the square root of all that. We've got 1, add 49, and therefore the square root of 50. So these are the components that we're going to need to substitute it into the formula here. I'll do that on the next screen. Rearranging the formula there, because we're solving for cos of theta, I'll write the formula out there. Then we're going to substitute in the numbers that we know that we worked out on the previous screen. The dot product or the scalar product is negative 11. The length, the magnitude of A is root 13, and then square root of 50 for the length of B, and that is approximately equal to negative 11 on the square root of 650. Using your surd rules that you can do 13 multiplied by 50. So that is the cos of that angle, then we need the inverse cos. And so the inverse of that gives us for the angle 116 degrees, and that's greater than 90 as we were expecting. So we have found the angle between those vectors. So given A, B and C here, which are points, we're asked to find the measure of angle ABC. The tip that I like to do is, as often as you can, create a picture, a visual for yourself. So plot those points. It might help you picture what you're going to do. Let's pick an origin approximately here. So for A, we're going across 2 and down 1. There's A, do B and C. Horizontally across 3 to the right and vertically 4. There's point B. And from that origin, going left 1 and up 3 for point C. And so we're asked to find angle ABC. So you can imagine that it's this angle between them there. We need to identify a vector A and a vector B. Let's call this one vector B and this side vector A. I'll rule in the third side. Let's do some calculations on those vectors then. So as you remember from the picture, we had B, C and A. We'll call this side vector B and this side vector A. So first of all, for vector B there, we're going to need to know, well, what it is. So we need to use the coordinates of C and B. So you take the position of C, the negative one, and you subtract off the first component of B, comma, the 3 here, subtract off the 4 from B, and that's going to give us the vector -4, -1. Now the next vector, perhaps I'll call that little letter B. The next one is, now, which direction are these going? That's BC going that way, and that's BA going this way. So I'll call it BA, and I'll say that's equal to vector A, and working that out. Because A is in the second position, we do 2 subtract 3, and then the -1 from A, subtract 4, working that out gives us -1, -5, and that's vector A. Next, to do the dot product, we need to multiply those two vectors together. So we take the x components of each, so I've got this -4 and -1, I'm multiplying together, and then I'm adding on -1 multiplied by -5, lots of negatives, be careful with that, and we've got that is equal to +4, add 5, and that's equal to 9. And the next step I also need to do, perhaps I'll do it on the next screen, is working out the magnitude of each of these vectors as well. So doing that, the magnitude of vector B and the magnitude of vector A, doesn't matter which way around I do these, you'll need to have reference to them. So we've got, for vector B, it's 4 squared, so that's 16, and -1 squared. So we've got the square root of 17. And for vector A, we had -1 squared and -5 squared. So the square root of 26. So now we have enough information to find the angle between them. So we've got cos of A dot B over the magnitude of A and B. Working them out, or substituting in the values that we know, the scalar product was 9 over the square root of 17 and 26. And doing inverse cos to solve for this, 9 over the square root, using surd laws, 17 multiplied by 26 is 442, and that's approximately equal to 64.7 degrees. That's an acute angle, and that matches with the fact that we had 9 is a positive number for the scalar product, and that is our angle between those two vectors. Join me in the next video, vector projection. Subscribe to the channel. Thank you.